Hello, Algebra 2. This is your last set of notes for this unit. So go ahead and label your paper 4.4 Regression, which is a new word for you. And all it means is that we have been talking about quadratics and linear functions. And what I'd like you to do is pause the video. Oops. There we go. Pause the video for a moment and try to match. If you notice, we have a bunch of points on each of these graphs, and they look like they are correlated in some way, shape, or form. They look like they might make a linear function or they might make a quadratic function. But go ahead and pause here and see, is graph 1 quadratic or linear? Is graph 2, 3, and 4 quadratic or linear? Which ones are they? Go ahead and pause and try it out. All right. If you said number 1 was quadratic, you are correct. Number 2, also quadratic because it has this curve right here at the beginning. Number 3, also quadratic. And number 4 is a little bit more linear. It's a straight line. Okay? You might remember this from Algebra 1, but with your different functions that you guys have, you have a bunch of points. You have a scatter plot. With these scatter plots, you are trying to find a curve or a line that best represents the data. So if you notice for the linear, number 4, if I drew a line directly through the middle of those points, and I tried to get some of the points above and some of the points below, that would be a pretty good approximation for the line that fits that data. That is exactly what regression is going to do for us. To have a formal definition of regression, really it's just the relationship between selected x values and y values. Okay? So if you take a look here at this quadratic, you'll notice that originally all these black points, right? There are some that are above the red curve, some that are below, but when we actually found the equation that best represented the data, it came out to be sort of in the middle. It's this red curve that goes straight through the middle. Same thing over here with the linear function. I have a bunch of points, and when I actually found my line, my equation that should match these points, it kind of goes straight through the middle. There are a couple points above and a couple points below. That is exactly what we're going to do. You can do this by hand. However, your calculator does find the regression equation very efficiently and much faster than we could do by hand, but it actually finds a much better approximation than what we would have time to do by hand. So we do rely on our calculator for this portion. So for some of you guys who really prefer to do everything by hand, I love that, but for this part of our unit, we're going to do this on the calculator. What we're going to do first is take a minute to enter data. Anytime that you are asked about a regression equation, also called a curve of best fit or a line of best fit, and we'll talk about that later as well, you need to collect or you need to be given data, all right? So if you're not given data, you'd be asked to collect it somehow. But we actually have data that's given to us right here. These are different countries, and we've been given the life expectancy of human beings based on the number of people per TV they have in their country. So this was data that was collected to see if the number of TVs in a household affected the life expectancy, which is kind of interesting. I guess they were thinking maybe people are more sedentary or maybe they don't move around as much. Does that affect how long we live, depending on how many TVs we have? I don't know. So that's what we're going to try to find out. Since your life expectancy is listed first, usually the variables that are listed first are going to be our x values. It's also what is kind of our set, right? Our independent variable. So we're going to say our life expectancy is our independent variable. And we're going to say that the number of people per TV is going to be our dependent variable. All right, so in order to do this, we are going to use your calculator. We are going to push the stat button. If you have a calculator in front of you right now, go ahead and try this. If not, write down these steps. Number 1, we're going to go to Edit. We're going to enter our x values in L1 and our y values in L2. Okay? If you don't have a calculator in front of you, you're going to come with me to my calculator. When you guys turn on your calculator, we're going to go to the Stat button, which is right here. And Edit is the first thing that pops up. It's the very number one right there. We edit anytime that you want to enter data. The L1 column is where we're going to enter our X values, and the L2 column is where we're going to enter our Y values. If for some reason you get here and there are numbers already in this column, you just have to go up to the L1 so that you're highlighting the L1, and you're going to push the clear button and down. All that means is it's going to clear everything that's below, everything that's down from L1. And you do the same thing on L2 if you're having any issues with the values already being in there. So go ahead and do so. And then we'll go ahead and start to enter our data. So I'll start with you guys. We have 44, 77, and 50 all in our L1 column. So we're going to enter 44, enter, 77, and 50. Go ahead and pause here and take a minute to enter all the data into your calculator. All right. Once I've entered everything on my calculator, I just want to make sure that I haven't missed a number. So I should have 22 items in my L1 column. It says 22 right here. And I should also have 22 items in my L2 column. So there are 22 data points that I'm entering. Let's go ahead and move on to step 2. In step 2, we want to find the best regression equation. That means that I want to find the equation that matches my data the best. In order to do that, I'm going to go back to my calculator. Stat button is where I'm going to do all statistics, so I'm going to use the Stat button. We're going to move to the right where it says Calc, and then we're going to decide, we're going to do this, both of them, that number 4, which is linear regression, so does my data look like a line, or number 5, does my data look like a quadratic? So does my data actually look like a line, or does it look like some kind of parabola, right? So let's go ahead and try that together. Grab your calculator, or write down the steps with me. We are going to go back to the Stat button. We are going to move to the right, so use your right arrow. Go to Calc. And if you guys notice, when you scroll down, number 4 is lin reg, so for linear, and number 5 is quad reg. You can see there are a whole bunch more down here. Cubic reg, quartic reg. We're going to get to those later in the year. But right now we're just dealing with 4 is linear and number 5 is quadratic. Okay? We're going to do both. So we are going to press enter on lin reg. Let's do the linear first. And let's go ahead and push enter. And we are going to write down this equation. If a is negative 5.58, that's my a value, so I'm going to put it right in front of the x. And then 414.7, we're going to put that as my b value. So negative 5.58, let's write that on here. That has the x next to it. And then we're also going to grab the b value, and that says it is 414.71. Okay. We are now going to do the same thing for the quadratic. So let's go back, and we'll do the same exact steps. And we're going to get the quad by going to Stat again, move to the right, Calc, and this time we're going to go down to quad reg, which is number 5. Enter and enter again, so enter twice. Go ahead and write down 0.19. We're going to round that correctly to 2 decimal places to the hundredths place in front of our x squared. Negative 29.66 next to our x. And then 1,150.35 as our constant term. Go ahead and pause here and write those in. Now, unless we actually graph both of these, we're not going to really know which one is a better fit unless we use something called the correlation coefficient. Step 3, we want to compare the r and r squared values. These values represent something called a correlation coefficient. Fancy name for How well does my data actually fit the line that I just created, or how well does my line that I just created or curve that I created fit my data? We really want our R value to be close to -1 or +1. So if I square -1 or +1, the R squared value is going to be close to 1. This is an important box right here. We want our R value to be close to -1 or +1, or the R squared value to be close to 1. Now, where in the world do I actually see these R values? If you guys look at our calculator right now, or at least my calculator, they should show up right here, and there's nothing there. So if that's happening to you, if you don't see an R value, we want to go down to second catalog, which is at the 0, and we want to scroll down to where it says diagnostic and turn the diagnostic on. So for my calculator, I'm going to go to second catalog, which is 0, and I'm going to go all the way down until you guys see diagnostic, and then turn the diagnostic on. We are going to have to rerun our test, which is no problem. It'll take 2 seconds to do. But we definitely want to have a diagnostic on so we can see that value. All right, so go ahead and find that. I'm going to have to go back up. And then push enter so that you guys have the diagnostic on. There it is. So diagnostic on, enter. And then it'll ask you, do you want me to turn the diagnostic on? Yes. So push enter again. Now it says done. So and we know that it did that. So let's go back. We're going to go back to stat, calc, and we are going to run our linear regression. And what you'll notice this time, when we do it, there's going to be an R squared and an R value. So let's look at our R squared value. We want the R squared value to be close to 1. Our R squared value for the linear is 0.64. So let's write that down. Okay. Let's go back and do the same thing with the quadratic. So we're going to go back to stat, calc, and we're going to just running the same test that we just did again. But this time we should see the R squared value pop up. For this one, the R squared is 0.70. Okay. So we've now compared both of our R squared values. Those were our R squareds when we looked at those. Which one's better? The quadratic is better. It's not better by a whole lot. They're not great. Usually we want them to be closer to 1, like 0.9 or something like that. But this one is definitely better than the linear. So we're going to say that quadratic regression is the best for the data that we were looking at. So that means that this data that we were seeing back here, this kind of looks more like a curve than it does a line. Okay? All right. So step 4, once you guys choose the best regression equation, which for us was quadratic, we want to predict, you might be asked to predict a future value. So for example, in this question it says, using your regression equation, predict the number of people per TV when the life expectancy of a country is 50 years old. If we go back and take a look, it says life expectancy is 50. If you guys look back at our data, life expectancy was our X value. So basically all it's saying is when X is 50, what's Y? Well, if that's the case, then all this is a problem of substitution. So let me go ahead back, and I'm going to write down, since we decided on quadratic, I would like to make sure that my quadratic equation is written down here. So let's go back and grab it. Oops, there it is. My quadratic equation. I'm going to go ahead and highlight it and copy it so that we can put it on our new sheet here. All right, so now we have the equation that we used, and I'm going to just substitute X with the 50. Once I do this, it will be pretty simple to figure out what are, how many people per TV are going to be in this country. Let's go ahead and simplify. There are approximately 142 people per TV.